Hi, I'm Dr. Bruin and welcome back for part 18 of this narrated series of videos that sit alongside my A-level chemistry speedrun series. This is a quite straightforward ideal gas equation question. So to start with, we're going to write down what the ideal gas equation is. And I'm always amazed in A-level chemistry that there are lots of things that we just take it for granted you can remember, and yet stating this equation is often worth a mark. And then we're going to rearrange this because we're trying to calculate the volume. And of course, remember that the volume as given by the equation is going to be in meters cubed, which is always an area that trips students up. Next, I need to do a couple of other conversions. So the temperature that I've been given is in Celsius, and that needs to be in Kelvin. So we convert that by adding 273. And then, of course, the pressure is given in kilopascals and we want it in pascals, so we need to multiply that by 1,000. Usually, if you do those two things, that's worth a second mark to you. So then, in order to work out how many moles I've got, I'm going to need to use the relative formula mass. So to calculate the relative formula mass of ethanol, I'm going to add together the relative atomic masses of all of the atoms that are in that compound. And again, this can often be worth a mark, and it's a really easy mark to lose. So just make sure that you're double checking those calculations. And then we're going to use our favourite mass is Mr. Mole equation rearranged so that the number of moles is the mass divided by the MR. And so when I divide 4 from the question by the MR that I've just calculated, then I get this long string of numbers. But of course, I'm not going to round prematurely. You're always going to write down your full calculator display or just keep using the answer button on your calculator. Do not round early because then you're introducing uncertainty into your answer, and it will be really silly to go through all the correct operations but miss a mark because you were just a little bit shy because you rounded too early. So if I plug all the numbers that I've now got into my ideal gas equation, the rearranged one that I did there, then I get a value of 0.0027314,609, remembering of course that that is in meters cubed and we need to be in centimeters cubed. Now, if you're not very good at remembering how to convert between meters cubed and centimeters cubed, the way to think about it is you probably are very good at converting between meters and centimeters, right? Pretty much everybody knows that there are 100 centimetres in a metre. So what is 100 cubed? Because it's centimetres cubed. So 100 cubed is in fact a million. So if we multiply our answer by a million, then we get 2,731 point blah centimetres cubed. But don't forget that the question also said 3 significant figures. So of course I'm going to count down the 3 figures at the start, and then it's the 4th figure which is going to determine whether I round up or down. Here it's less than 5, so therefore I round down. So my final answer is going to be 2,730 centimetres cubed to 3 significant figures. Thanks very much for watching, and I hope you're finding this series useful. If you are, then don't forget to like, subscribe, comment on the videos to tell me what you'd like me to cover next, and also share the channel. And I'll see you back soon for some more A-level chemistry.